suppose we wanted to do one more step. Suppose we wanted to find the inverse from a graph. So suppose I give you a graph and I'd like you to graph the inverse function. Well, there's a couple of ways that we can actually do this. The first way is we could take a group of points and just re-graph the points. And so if we were to do that, we would actually realize that if the point AB is on the graph of Q equals f at x, then BA is going to be on the graph of f inverse of Q. So we know this has to be true because we've said before, the domain of the original function becomes the range of the inverse function, and the range of the original function becomes the domain of the inverse. So suppose I kind of do a little bit of baby steps getting myself there. Here's a graph of f at x. So this is my function f at x. Let's just do some computations, get ourselves kind of worked up to where we were. Suppose I wanted f at 2. Well, remember back from the very beginning of the course, the statement tells us that x is 2, and to find f at 2, we just get the y value that corresponds to x equals 2. If you read off the graph, you'd learn that y would be 6. So f at 2 is 6. Again, we did this right back in the first section of the course. Part B, suppose we wanted f at something is 17. Well, again, remember this tells us the 17 is the y. So to figure out where f at x is 17, what we did before was we determined the value of x that corresponds to y is 17. When we do that, we end up getting x is 24. And so f at 24 is going to end up giving us 17. Now, suppose I want f inverse. I have done a couple of f-type things. Suppose I want f inverse. Well, what we need to remember is kind of an important statement, right? If f at A equals B, then f at B equals A, and it's not f at B, it's f inverse at B, equals A. So if I have f inverse at 9 equals blank, this is the same as actually saying f at blank is equal to 9. Right? And so we're going to do this problem very similarly to what we did in part B. And so if we went and we did that, we now know that the 9 is the y value. And so we would go and find the corresponding x, and when we did that, we'd get f inverse at 9 is going to give us 8. Very much the same as we did B once we do the rewrite. What about f inverse at blank is 0? Well, again, I don't work well. When the graph is f at x, I don't work well trying to think of f inverse. And so if my graph is f, I convert this back to an f statement. So if I convert this back to an f statement, f inverse of blank is 0 is the same as saying f at 0 is equal to blank. And so now I know the 0 is an x value. So I go to my graph to where x is 0, read off, and I get 5. So that tells me f at 0 is 5. So f inverse of 5 is equal to 0. So it's just kind of reading off. And again, I convert everything back to an f statement. Now, if I wanted to draw the graph of this, I could actually take these as a group of points, these inverse values, as a group of points and graph them.